when the bobbin case is locked into the machine and you pull on this, you want an even, steady drag. And if you feel that pull on that thread, that's a lot of drag. It's pretty tight tension. Could be because the bobbin case is broken, might be bent and rubbing on the outside edge here. But the bobbin case tension, you want just about as light as you can get it without the screw falling out. Depending on the density of your webbing. Yeah, when I put this in, there's a considerable amount of tension on it for some reason. If I have it out of the machine, it's free flowing right now. As soon as I put it in, it more than doubles the drag. Oh, that's better. That's much better. As you can see, the spring is actually not even contacting the thread there. You just want enough drag on it to control the thread. Oh, I see. So this pigtail here, that's this thread guide, it's held on by this screw. And this should be facing the right like that instead of to the left the way it was. Oh, now feel the drag on that. Half of what it was. Yeah. Even, steady. And they could all be that way. Problem is, again, the variable is bobbin, the pre-wound. Very difficult to get it that light because of how it's wound and bound onto the core. Oh, so while we're here, now this check spring. This check spring, as the machine is running, this gets threaded through the main tension, behind the spring, and under this bar. And that's basically like a shock absorber. As the machine running and the take-up lever is whipping up and down, it has to pull thread from the spool through the machine so that the hook can pick it up and handle it. So the more pressure you have on that spring and the length of the stroke, the more load it puts on the thread. And the way that spring is made, it's held onto the end of this stud. It's got a coil with a little leg that goes into a groove on the end of the stud, and the pressure on that is set by turning the stud and winding the spring up or decreasing the spring. And that's also a 3mm Allen wrench. And there's a set screw right in the bottom of the frame right here. And once you loosen that, we can just take that whole thing right out. And what I'm going to do is unwind that spring. Some of the pressure, it's got a set screw actually on the inside too that I probably got to loosen. And if you ever take this out, beware that there's this little pin that goes right in the center of that. And when the solenoid, when the machine goes through its trimming process, there's a solenoid that energizes and presses a rod against the end of that pin to open the tension so that it is actually released. Because during the trimming process, the moving knife that's kind of got a point to it has to travel in, pick up the needle thread, and then carry it back to the fixed knife tension free. So during those few last degrees of rotation, a few milliseconds is all it takes, the tension is actually open so that it can accumulate enough slack so that you have a thread sticking out of the needle to start the next sewing path. If this is not functioning properly, you get a real short tail up here and the thread constantly flying out of the needle. There's several things that can cause that in addition to the tension not opening, and one of those things is how you guys have this threaded right here. So the more holes that you go through on any guide, the more drag it's going to put on the thread. This could be open all day long. If the thread is wrapped around something up here, it's like this not being open. You'll get the same result. So my personal preference is I usually just use this bottom hole and one of these holes. But depending on the quality of your thread, you may not have the issue. It's just a personal habit, because sometimes the thread comes from the manufacturer and the bonding aid that they use to hold it onto the spool is the same like when they wind the bobbins, and it doesn't feed off the spool freely at all. And if that gets restricted back here during the trimming process, again, this could be functioning fine and you're trimming short. So my personal habit with heavy nylon thread like this is above 207, 277, and 346. These machines can't handle 346. When you get above 207, even 138, I tend to thread just through one eyelet, because I want the thread flowing as freely as possible, and then I set my drag with the tension, the main tension. So there is one small set screw in the base right here. You might as well just take it out while we got it out. And when I loosen that screw, this whole thing just spun in my hand. So there's the spring, and on the end of the shoulder of the tension unit is a little groove milled in there, and the spring has a little leg that's sticking down into the ID. So when you put that on there, as you turn this, it'll eventually catch, and you can wind it. You'll feel the tension on the spring. I usually just engage it slightly so that the spring returns. This was wound up to about like that, and a lot of pressure on there. So that's a very heavy spring, and I usually set it just about like that. I like to take as much pressure off of the thread as possible. Yeah, once we put this in, you guys can check and see how it feels. Now when you put the tension back in the frame, the resting position of the check spring is critical too. Right now it's basically straight up at 12 o'clock. That's far too much stroke in relationship to this guide right here. So in the book it'll show you, because when the machine is running, this air cylinder activates and this lever actually moves up and down. Because after the trimming process, during the sewing, this is up. Then after the trimming process, the solenoid energizes this cylinder, and that bar comes down and pulls off thread again for your starting thread. It creates slack. That's the whole purpose of that thing. So you want the stroke of that to be fairly short when this is sewing, and I use just a visual reference of around, if you're looking at that and this is 12, this would be 9 o'clock for the end of the spring. 12 o'clock is straight up there. I move this down to about the 9 o'clock position right in there. And then you'll see when we turn this on and thread this up, as this moves up and down, the spring is still actuating during the sewing process. And basically, like I said, it's like a shock absorber. As this lever whips up and down, it just keeps a little bit of pressure. If you ever were a kid, you're swinging on a vine, you got the slack, and you jump out. And so that spring kind of controls that a little bit, is the best analogy I can make. And then, so right about there, and tighten up the screw. So now, let's thread up the rest of the machine. So right now is the condition that the machine would be in when you're doing normal sewing. As the needle comes down, right now the needle is at bottom dead center, and you can see that the thread is in the condition of my first drawing there, going down through the needle, through the eye, and being drawn straight back up through the needle hole bushing. Now as the machine continues to turn, just that 2.5 millimeters right there, if you can focus, you can see the thread is now relaxed and formed a loop for the hook, because the hook is coming around. It's going to be able to pick it up right off the needle nice and cleanly. And now this shield comes into play here. The thread is actually going to ride on that shield, because what a lot of people don't understand is that when the machine is making a stitch, half of the thread comes over the top of the bobbin case, but it's actually a loop like this, and the other half is going behind the bobbin case. And I don't know if you can see back there, you see the other half of the thread? Yeah. Is behind the case. Very few people realize that. That's what's unique about this type of stitch formation, lock stitch, which you have all of your machines. You don't have any chain stitch machines here. Well, a serger is a chain stitch. It runs off of spools, there's no bobbins, okay? Being a lock stitch machine, that's what's unique and very specific about it, because the needle thread encompasses the bobbin thread by 360 degrees of a sphere, every angle. And that's what allows the two stitches to lock together and not come back apart. Like on a chain stitch machine, you see a potato bag or something in the store and you grab one end and there goes the whole seam. That's not allowed with this particular type of product line that you're making, and what makes this machine unique. So, and now you'll see that the thread, as the take-up lever now starts traveling up, there's the whole needle thread, that whole loop, the whole circle that I was just talking about. And as this comes up under the tension that you have your dial set on here, it pulls right up into the material and completes the stitch. Every time the take-up lever here gets to top dead center, the stitch is complete. When this is in its off resting position, this little adjustable leg here, this got a screw on the top, should be facing almost 12 o'clock straight to the front. What happens is this spring, they push that on so hard that it bends, and go look at the machine and see if this is laying right against here. There's no gap between the spring and the lever. So then what happens, you push it on so far, underneath there's just a little plastic cam that has a spring on it. And if it goes past the whole thing, the spring goes behind it, and now the lever don't work at all. I've taken that apart 10,000 times too. And sometimes the little plastic part that holds the spring, if somebody forces the lever back, breaks, and then you have to replace it, just that part. So that's something to look at on the ones that aren't winding. They should wind. Because really all you got to do is take the lid off, and there's a spring that holds the follower against that little plastic cam, kind of pull it to the side and get the lever back on the right side of it, and then because most likely that its resting position, once you get it on the back side, this is going to be pointing like out here somewhere, because that's held with this 3mm screw. You loosen this one, I can set this anywhere I want. And if the spring gets collapsed against the lever here, then people loosen that and adjust it so far in, eventually it comes right off of that cam I was talking about. Okay, comb it up. And you can hear, as the machine's running, it's got a constant same sound, very smooth. So your starting thread is the other thing that we were mentioning on these machines, should be about 1 inch or 1.25 inches long like that. And again, if we weren't to change any variables except how this is threaded, if we just go in the bottom hole here and one of these holes, if you don't have silicone in here, you might as well not go in there either, because that creates a very shallow angle from the top of this to this tension here. This tension, this nipper tension, all that's for is to control the length of this thread. Because during the trimming process, the main tension is open, and then this takes over. Just put enough drag so that the moving knife can pick up the thread and control it. So if you're not using this, I recommend threading it like that, because now I have a much steeper angle going into here and it can't come out. And then again, this particular path here, where it's going in and out, if anything, go in and around, because that adds a lot of drag right there. And you'll probably find that when you go over a corner like that, even though it's very polished, you're going to have thread residue. You'll see white powder, white goop from the thread accumulating in certain parts of the machine because it's kind of like scraping at the thread. So, and I can see some right there, yeah. When you feed across what I call the grain, this has weaves, well, this is woven material. So you've got one weave going a certain way and different materials are woven differently. So the way that the stitch, if a needle comes down on one side of this grain and the next stitch is in the middle of it and the next stitch is on the other side of the next grain, even though it's a straight stitch, it looks like it's at an angle. Just because of the weave of the material. You won't change that. That's another good thing about the electronic machines is that, and if you watch this lever now here at the end, see how that came down and it pulled off slack to give you your starting thread. You can't tighten the tension so much to get so short of a tail that you don't have to cut it off later, because if the tail gets too short, it's not going to start sewing in the first few stitches. You'll see it'll sew for maybe 10, 12 stitches and then start sewing. That's tail length. Because it's too short to go all the way around the hook, like I showed you there by hand, and until it agitates and pulls off enough thread to make it go around the hook. That's why I'll skip first several stitches and then boom, start sewing, because it's pulled out enough thread. So depending on your sewing pattern. Now, if you guys were using the presser foot, then the wiper would wipe the thread up on top. The presser foot has a barrel on it, and it couldn't go back down inside the clamp. So most likely all you've got to do is pay attention to how you load the machine, because your cavity is big enough there that it's going to be pretty difficult for the tail to get trimmed unless it's really, really long. So this one here is about 1.25 inches long, and you can see how that's pulling back. But being that this travels down, and as soon as I start the machine, this is going to come up, and that allows the machine to use this little bit of accumulated slack there to start sewing. Oh, we got no bobbin. Oh, we got bobbin thread. But there's the perfect example right there. It missed the first 4 or 5 stitches because that tail was so short or a little bit frayed. So, and you can see as we take this out, it's got a lot of tension on it. You can see there's no slack in this thread anywhere. Again, you have to weigh it out between trimming the tail and having to re-sew it, I guess. We want the bobbin thread, and that's another reason for the bobbin thread to be as loose as possible, because the tighter this one gets, the tighter this has to get to achieve this. Because if I was just to loosen this top tension, loosen, eventually you're going to start getting loops on the bottom, and the looser I go, the bigger the loops are going to be.